This is 152, and we're down to investigating Windows systems, the first part of 3. This chapter has a lot of detail in it, stuff I'm very familiar with from my days teaching Windows tech support and forensics, but there's a lot of artifacts in the Windows system, and that's what we're going to talk about, and then I'll have demos at more Velociraptor. So let's take a look at it. Oh, by the way, we're not getting as many people as is recommended to me, the CCDC team. So if you're interested, sign up on this form. We could use some more. We will have an invitational in the beginning of December, and we should have the team, putting a captain, meeting to practice, and all that stuff before then. So if you're interested, go to my homepage and fill out that form. We could use some more people on the team. And here. So Windows systems. Here's what we're going to do. Today we're covering these topics: the file system, prefetch, event logs, and scheduled tasks. And later on we'll have the registry and other artifacts like memory forensics. Also, I should mention, another thing has reminded me of it. I did another test today. Remember I talked to you last time I saw you about LastPass, and I added it to this, I think I added it to this class. Maybe I didn't. Let's see. No, that's my malware analysis class. All right. In my malware analysis in my forensics class, I've been doing memory analysis of LastPass and finding how easy it is to steal all the data from LastPass, and it turns out to be very easy. And a lot of people freaked out and said, maybe we should quit using it. And I said, I don't know if the others are any better. So I looked at the top-rated product called Keeper, and I tested it today, and it has the same flaw. So as I thought, even though it is very easy to steal the data from LastPass, it is not clear that there's any other product you should use instead. I'll continue doing tests and see what I can find, but it seems to be true that all of them just leave all your secrets just sitting in memory unencrypted all the time your computer is on, which is surprising to me, but that does seem to be how they work. At least that's how those two work on a PC, which is the only thing I tried. On Android, it doesn't do that, but it has other flaws. Anyway, so the NTFS and the file system. In the old days, Microsoft used FAT, which was used on floppy disks and used in Windows 95 and Windows 98. And this was an old system that could only handle volumes up to a relatively small size, like 2 gigabytes. And a bigger problem is the files had no permissions. So any physical access to the machine meant you could read and write every file on the drive. And that was one of the many reasons why they invented NTFS, the New Technology File System, to be more secure, among other things. And instead of having just a fixed size file allocation table, which only has so many records, they have a master file table, which is a database, which can store a lot of information about each file. And now you can have a whole list. These users have read, and these users have read and write and execute and so on. You can have a whole access control list attached to each file. And so that's what the master file table does. The master file table is, I think it's a megabyte in size, and there are 2 copies of it kept, so you have a backup in case one gets corrupted. And this is the directory to everything on your disk. All the active data is here with a file name, an owner, an access control list, timestamps, and a list of clusters where those data are actually stored. And that's the directory to everything on the disk. All the active data is in here. So, therefore, to get the evidence off a drive, you want to get the master file table. This is stored in the volume root as a file named $mft, and you can't read it normally by just opening my computer in Explorer. You have to have raw disk access, which you do not get through Windows Explorer or standard API calls, so no normal software can get it. You have to use a forensic tool to get it, like FTK Imager. And so you can also do it in Velociraptor. Velociraptor totally connects to the $mft. And if you do there, you can see the master file table. Here's the master file table, and here's some other control files like log file and attdel, attribute definition, and so on. And here's the recycle bin. These are things that are stored with a $sign. Dollar signs are at the start of files that Windows does not want to be displayed in the GUI. They're the equivalent of the dot in the Linux file system. You make a file start with dot, and then it will not appear in most displays because they're system files you're not supposed to be messing with. So it's all right, on a standard hard drive, it's a series of 1 kilobyte records, 1 for each file and 1 for each directory. The first 16 entries are reserved for essential artifacts like the MFT itself, log file, and some of those other things we saw. And you can see it. There's a tool called WinHex that will let you see it directly on a Windows machine, or you can use Velociraptor to see it remotely. And so here you see those 16 files, MFT, MFT mirror, secure, volume, boot, and so on. And then after that's all over, then you have a couple of normal files, file 1 and file 2. They're there, but they don't start with a $sign, and they will appear in the normal Windows Explorer. So in there, you've got record type, a record number, parent record number. You have a mark of whether this record is active or inactive. Technically, when you delete a file, it might be just marked inactive, and in fact, all the metadata for that file might still be in the MFT, and you might be able to undelete it and get it all back. In practice, that almost never happens because Windows, the system volume is constantly creating new files and overwrites it very quickly. I tried to make a project where you delete something and then recover it, and I found that that doesn't work very well. In order for that to work, I think I'd have to have a second volume there that's not the system volume, and I might make a new machine there. Some students are noticing that the Windows 10 machine is failing its activation, and you can't renew it anymore. So I think Microsoft has finally busted me for all of you using the same one, so I probably have to make a new one. And I'm thinking I'll make a new one with Windows 11, and maybe I'll make a second volume on there so we can do things like this. There'll be a non-system volume to try that. So I'll let you know. In the next week or two, I may make a new machine to download and use if you want to get one that won't keep shutting down every hour to punish you for not being activated. And so here's information you have, like standard information, file name, and data. So there's a record header, here's the standard information, then there's the file name, and then there's data, and the whole thing has 1,024 bytes to work with, which is really a lot. And you can pick up all this stuff in Velociraptor. You can collect MFT records, and you can reconstruct deleted files in principle, although when I tried to do it on the system volume, it didn't work very well. So I'll try adding another volume and see if it's more reliable. Then it would make a good project. So deleting a file causes it to be marked inactive. Nothing will change until that record is reused. But like I say, the problem is NTFS will always reuse an existing entry before creating a new one, and the operating system is constantly creating new log files and stuff, so those entries get overwritten in a hurry. All right, there's a lot of timestamps on a Windows object, file or folder. Modified, accessed, created, and entry modified are the main timestamps, and it's always got two sets of those four things, the standard information and the file name. The standard information is what you normally use. When you go to the properties of a file or folder, you see some timestamps here, created, modified, and accessed. Those are three of those four. The entry modified timestamp is not visible in Windows Explorer. You can get it with forensic tools, but you don't see it here. And these are all the SI timestamps. The other ones are not visible anywhere in the Windows tools. So modified is when the contents of the file was last changed. Accessed is when it was last read. Created is when the file was first made. An entry modified is when the MFT entry is created, so that's when the metadata of the file is changed, like the file name or the owner or the permissions. So the access timestamp is no longer updated correctly after Windows XP. It's still there, but you can't trust it. Theoretically, it's not updated at all, and even if you turn on the update, it might be wrong by an hour. So this is real important when interpreting these timestamps. You really have to do some research, reproduce things, and see how much you can trust them, because timestamps are often very important to prove who did what on a machine, and you have to be very careful because there are ways the timestamp can be wrong. Another thing that's very common is criminals will change the time zone or the time setting on a machine to make it appear that something happened at a different time, and you have to look out for that. So the FN timestamps refer to the master file table itself for the master file table entry, and they have another 4 timestamps in there. And by the way, there's 2 file names for every file, and maybe even more than 2. There's only 2 I know of. There's the MS-DOS 8.3 file name. This was the rule in MS-DOS. Your file name could only be 8 characters and then a dot and 3 characters for the extension, like autoexec.bat. And the modern systems still preserve that. Every file has an 8.3 name, and they also have a long name, and you can refer by either one. Only people that are really old-fashioned and remember using MS-DOS would deliberately use the 8.3 file name, but it is still there, and you can still use it. So time stomping is something that criminals do all the time. They will do something bad, and then they will try to time stomp the time records on things like log files to make it look like things they did are not created on that date. It's a very common thing to do. A lot of hacking tools will do this. If they're putting tools on the machine or files on the machine, they'll stop the time to make it look like those are at a different time. And the thing about it is, programs can only alter the SI timestamps. Now, there are some programs like set MACE that can alter them all, but a lot of hacking tools don't alter them all. They just change the timestamps you can see by just going into a file properties. So that's why it's good that both files are there. You might notice that the SI timestamps have been changed, but the FN timestamps are still preserving the old original time. So a clue that something bad has been happening is you'll see the SM timestamps have been changed to 2006, but the FN timestamps are 2009. This is not something that would normally happen, and that indicates that these have been stomped. And the stomping tool did not get these. So that's a reason why you might care about all these redundant timestamps. And there's a SANS poster with a lot of information about the artifacts you can get. And it's kind of nice, you know, you got the most recently used list. You have Skype history and such for file download. Then for program execution, we talked about a lot of things. You got prefetch. You got most recently used. You have user assist. We talked about a lot of these. And for file opening, there's another list of things. So it's a list of some of the useful artifacts on a Windows machine, of which there are hundreds. So let's start with a Kahoot. I got 12A1 in here, presumably. Right there. Nope, that's 12A3. All right. 12A1. All right, that looks like the right one. Stop the trooper. There you go. That's a good idea. Well, you got 10 people in the Twitch. Oh, good. Getting at least 4 here is better. There we are. Good. Getting more than 3 is better. Otherwise, the competition becomes degenerate. I'll give it a couple more seconds. Oh, okay, good. I'll give it a couple more seconds. We may have more people coming. All right. All right. So where's the normal modified timestamp that you see in a property sheet? It's the standard information. In this case, the name is pretty descriptive. All right, so what item replaced the fact table in the modern system? The master file table replaces the file allocation table. Good. All right, which timestamp is no longer updated? The access time, which is kind of a shame. That one would be useful, but for some reason, they don't update it anymore. All right, which timestamp is not visible inside Windows? The entry modified. That's the one that it does maintain, but you can't see it without a forensic tool. All right. Trooper will have to tell me who they are if they want points. I appreciate people competing to make the contest more entertaining anyway. And let's go back to here. All right, so the way it works, I used to have some projects. Boy, one time I taught my forensics course, we really went into this in great detail. We're actually fixing broken NTFS files. These things are called data runs. You have a cluster of data, which goes to the next cluster and the next cluster, and you have to put them together. And if your file is fragmented, it might have cluster 1000, 1001, and then skip to 1010, 1011, and so on. And you have to piece it back together. These are called data runs, and that's what's stored in the data attribute. It lists where all the clusters are that contain the contents of the file. So the master file table has 1024 bytes. It really doesn't need all that to store the clusters and the permissions and stuff. It doesn't need much at all for that. So there's a lot of extra unused space, like 700 or 800 bytes in there. So if you have a small file, like a little notepad file, it doesn't really make sense to go put it into clusters. Now the clusters are 4 kilobytes each usually, so you'd really waste a lot of space filling that up. So if you have a short file, it just puts it right in the MFT. It puts the data itself in the master file table and not in the clusters. And that's called a resident file, and there is a flag for that in the master file table entry. Those files do not have anything stored in the clusters out on the disk. And that means the master file table might have leftover data, slack space. If there was a resident file stored there, and then that file is deleted, and you use this to point to another file that goes off in the clusters, that old data might still be sitting there in the last few hundred bytes of the master file table record. So that's another place where you might find a fragment of a file. You probably won't find the whole file, but I guess in principle you might. All right, so there's data attributes, and if you want to have alternate data streams, you'll have additional data attributes. We've talked about this before. Each file name can be treated like a directory or like a drive, really, and you can have other files stored inside it. So you have various data streams tied to the same file name and the same timestamps and the same owner. And you can create these things. If you echo some data to out.txt, you can then echo more data to out.txt : secret.txt. And that will create a second stream of data inside the out.txt file. If you do a directory, you'll only see the main one, out.txt. But if you do a directory /r, you can see them both. That's the built-in Windows tool to see it. And you can use type, I think. That's what I would use. More. I'll use more instead of, yeah, you can use more to see what's in there. You can go to out.txt, and you can also print out.txt secret.txt. So all the data is stored. That's an alternate data stream. And you can also use other tools to see it. There's a tool called, well, we'll see it. And another thing an alternate data stream that's used a lot is the so-called mark of the web. It's in the news a lot lately because there's a bug in Windows. There are ways to make a corrupted zip file that will destroy the mark of the web. When you download something from the web, it's marked with a thing called zone identifier as an alternate data stream, and this is why Windows will pop up a box saying, this file is downloaded from the internet. Are you sure you want to open it? So that's called the mark of the web, and that's how they store it. You'll see it if you take a file like iTunes Setup. I downloaded back when iTunes was a thing, and then if you did a dir/r on it, you would see that it had a zone identifier on it, iTunes Setup, telling you that it's really from the web. So you could remove it, and then it would no longer be recognized as coming from the web. You could also use this program called Streams, which is a sysinternal tool, to see the alternate data streams. This will just tell you what's there, and this will reveal the alternate data streams, and you could delete it. You could use streams minus D to delete the alternate data stream, and now it'll no longer be marked as from the web. All right. So there are a lot of tools that can analyze the master file table. The main thing we're going to use is Velociraptor, but SleuthKit can do it too, which is Autopsy now. That's what we're using in my forensics class. And there's been a lot of these tools out there that can analyze the MFT and find the data on there. And so there's the index attributes that Microsoft has been struggling to index and make search engines for at least 20 years with very poor results. At one time, Google made a desktop search engine for Windows XP machines, and it would find files in less than a second. I just had to type the first 3 words of the file, it would find it. Microsoft cannot make a search engine that can find files on your own system. At that time, they had something called Rover the Search Dog that would take 5 minutes and often fail to find files on your own hard drive. And it's still the same. And they've been trying to make an index system. There's index attributes in the master file table for this purpose, but the end result is, as you probably noticed, it's still really bad. It's still really hard to find a file on a Windows system using Windows tools. Microsoft has some kind of mental block. They cannot make a search engine that works. Anyway, unfortunately, Google Desktop Search is gone. I would still be using it because the Google search engine to find files on your own machine was really useful. The Microsoft tools to do that are not very effective. Anyway, let's take a look at another Kahoot. 12A, 2. Bronze elephant. Oh, there we go. Might have another one coming. I don't know. There were 6 last time, but maybe not this time. I guess not. Oh, there we go. All right. All right, so which one of these is 1 kilobyte? Each master file table entry is a kilobyte. By the way, the whole master file table is a megabyte, so that would make it seem like you can only have 1,000 objects on a NTFS system, and I highly doubt that, so there must be a little more to it than that. Anyway. All right, which item lists the clusters that have a file's contents? That's the data. All right. I think there is a limit to how many files you can have in a Windows system, but it's a lot more than 1,000. Anyway. All right, which item contains timestamps for deleted files? That's one thing about the index. See, if you delete the file, it's going to remove the master file table entry when it gets overwritten, and all the other things will be gone, but the index will still have a record for the deleted file, which is a useful thing to know. All right, so where are active small files stored? The contents. Resident data inside the master file table. They do not need to go out to the clusters. the remaining bit. All right, so log file tracks transactions, things that change the structure, like creating a directory, or other things like changing index records. The USN journal is update sequence number. This is, I'm pretty sure, the journal that makes it self-healing. In the days of FAT, if the machine crashed with the blue screen of death or the power went out, it would be stopped in the middle of a disk operation often, and then when it started up, it would find a partially completed disk copy or something and have no way to complete it. So it would sweep up all these fragmented files it found and put them on the root of the volume and call them file 0000, file 0001, and so on. And this process could take 15 minutes. You'd see recovering lost clusters for 15 minutes when you rebooted. So to fix that, Microsoft updated, catching up to Linux, to make a journaling file system where it records in a journal everything it's doing. I'm copying a file from here to there. I'm copying the first cluster, the second cluster, the third cluster. Blam! The machine dies. Then when it comes back, it looks in the journal and it can figure out where it left off and just finish the job. So you're much less likely to corrupt your hard disk due to failures. And I'm pretty sure that's what this journal is. Anyway, volume shadow copies are another important thing for forensics. These have been around since Windows 2000 Server. And what it does is it automatically creates backups of files. And in modern systems, it creates them, I think, of everything. Not only the system files, which is where it started, but also the user files. It automatically generates backups. This is called the Volume Shadow System, and you can use the Volume Shadow System admin command to control this. So what you see here is an example of VSS admin list shadows for C, and it shows you there is one shadow copy at the creation time of this volume. And if you want to use the shadow files, you just use makelink, which is the same thing that you've got in a Linux system, to make a symbolic link to mount the shadow copy at a drive or folder location, and then you can look in there. And forensic tools like Autopsy will collect the shadow copies. I'm pretty sure Autopsy will. I know FTK and Encase will. And then you can see them. They're often quite useful. They have old versions of files that have been changed, and those might be very informative. So that's the game. Your shadow copy can be a mirror of the entire file system. And there's a lot of tools out there, Shadow Explorer and so on, to help you find it. A lot of forensic tools are useful for this, as well as the built-in VSS admin. And Velociraptor, of course, has a collector for shadow files, collects files, and not only this has VSS deduplication, because, of course, most of the files in the volume shadow files are copies of files that are still there. So there's really no point having two copies, and this will automatically remove the duplicates, just to avoid wasting your time looking at identical copies of files. So that's handy. So then there's the redirector. This is real important. Every Windows operating system supports, has one level of processing, like 16, 32, or 64 bits, but it always supports one generation back. So you can run 16-bit software on a 32-bit Windows, and you can run 32-bit software on a 64-bit Windows. But if you think about that, back in the days of 32-bit software, the Windows was different. The profiles were in a different thing. Now it's C user's username. Back then it was C, I think, documents and setting username, and many other things have changed. So if you install a 32-bit program, it tries to write to locations that no longer exist on a 64-bit Windows, and it tries to put registry entries that no longer exist on a 64-bit Windows, and so you could foul up your 64-bit system by installing 32-bit software. To prevent that, it uses the redirector process. The redirector process notices when you are using 32-bit software, and it puts those processes in a sort of container, like a virtual machine, although much simpler, where it just takes some fake places for changes to make. So some folders go elsewhere. Like when it tries to write to System32, it goes to C Windows syswow 64, which is Windows on Windows. And so, and you've already seen this, if you install 32-bit software, it does not go in C program files. It goes in C program files parentheses x32. A different directory, so you don't mess up the 64-bit system with the antiquated 32-bit systems. And the same thing's true of the registry. Registry keys are redirected to 32-bit images. So this is a thing to know, and this means if you run some kind of like an antivirus scanner or something that's 32 bits, it cannot see the whole file system or the whole registry. It only sees a mirror of that is for 32-bit software. So it's a thing to be aware of. This is how Microsoft manages to run old software on new Windows, which is enormously important for commercial purposes, and that's why they do it. Yeah,
Could you please say that last sentence again?
why they do it?
Um,
Why the tools don't pick up everything?
I didn't understand it, so I'm.
Yeah, I mean,
The very last thing that you just said.
well, the very last thing I said was they do this for commercial reasons. Because if there are any people have old software they've written at businesses that they don't want to rewrite. And I used to work and they'd have software written for Windows 3.1. And so Microsoft very vigorously supports old software. You can run old software on the newest platform, which Linux totally does not. You have to install additional libraries that are not in there by default to support old versions of things, and Apple does not. Very often when you put on an Apple update, a bunch of your software stops working. They would force the developer to change the software to run on the new version of Apple. This is why they're hostile to businesses, because businesses very often rely on something like their cash register software that somebody wrote 20 years ago, and they don't want to change it, and they want to keep using that same old software forever, and Microsoft is there for you. They're totally on board with that. And that often creates big security problems, because that old software is probably using antiquated authentication methods and everything, and Microsoft provides ways to downgrade your modern system to be completely compatible with MS-DOS and stuff like that, because people need it in business environments, even though it's low security. That's why when you make a domain controller, you have to choose whether you want a native domain controller, which will be much more secure, but it can only communicate with other domain controllers at the same version or later, or you make a legacy domain controller, which can interact with your old domain controllers. And if you do that, they allow that, but your security level is downgraded to the security level of the older systems. And that's why Microsoft is a fundamentally commercial business. I mean, they're there to serve business and make money. So if you need something, they will provide that, even if there are arguments against it. Whereas Apple doesn't want to do this at all, because it's a whole lot of bother to put out patches for old systems and to build all these horrible things in your new system to accommodate the old system. They just have no interest. They don't support anything older than one version back. Their opinion is you should throw away anything older than one version back and buy a new computer, as far as they're concerned, which makes it a whole lot easier for their developers and their security team. But it means businesses have a real problem using Apple stuff.
Yeah, I mean, that just kind of strikes me as, I guess, counter to like what I heard that Microsoft was going to be more security conscious.
Well, this is what they did. They made it so that it is more security conscious in a native install, but they have options to downgrade it as necessary for legacy purposes, and that's the compromise they made. So you can be secure if you don't try to use old stuff. But most people need to use old stuff, and that's more important than security. And they do add some features to try to improve security even when you run old software, but you can only do so much. I mean, you really have to recompile software to get all the newest features. So Microsoft is actually pretty secure these days. There's a lot less malware on machines than there used to be, but they have set themselves a much more difficult problem, which is making a system that will really work in a normal business environment and do everything you need, and also be secure, and that's very difficult. Apple just ruthlessly does not support things that you might need in business, and they don't care. Anyway, so the prefetch we talked about a lot. Prefetch is easy to use, very nice. You have these PF files created. Now on Windows Server, prefetch file is not populated. You can turn it on with a registry key, but on client systems it's populated, and it has the last 128 files that have been launched are just stored here with PF files, and that records how many times that program has been launched and when it was last launched. And the purpose of this, as you get from the name, is to make the machine work better. If you have a personal machine, you typically have a lot of memory, like 4 or 8 gigabytes. You don't really need all that, especially when you first boot up. So when you boot it up and then you open something like a browser and you start reading your email, it's just sitting there and all that memory is sitting empty. So while you're not doing anything better, it goes and fetches all the programs it thinks you're likely to use and loads them in memory so they'll load faster when you do use them. So that's why it keeps this history. It keeps track of what you seem to like best, and it preloads it. And so that's why it's keeping track of everything you do, just for that reason. And it doesn't bother on a server, because servers are not used that way. Servers are typically doing one thing, like a database server. They're not a general purpose machine used by a human. They don't guess what's going to run. They just load one thing and run it. And so they don't bother with the pre-boot process on them. So that's the point of this. For forensic people, it's very useful. Even if the executable has been deleted, it still has a record here, if it was one of the last 128 programs run, of when it was run, how many times it was run, and each component, and I think also who ran it. So it's very nice. It's a handy record. And so you can get a tool like Prefetch View. You can't just open these files. They're not text files. You can't open them in Notepad and see anything. But there are tools that will let you see it, like Prefetch View and Velociraptor. We'll just show you the files, and down here it'll tell you what they are. And so Velociraptor has a Windows forensic prefetch that will gather it and make it easy to see. See, on Windows 10, we can see the last 8 execution times and creation time. I'm not sure if you get the owner, the person that ran it, but you certainly get the time it was run. And then there's event logs. Microsoft has an extensive logging system. By default, it only collects a minimal amount of logs, but even that is pretty good. So failed logins and successful logins are in there, the start of services, the running of applications. If you turn on auditing, which is Microsoft's security policy, where you can record something like who's going in this folder or things like that, it will track alterations to that, user permissions, and a lot of your installed applications put up logs like your antivirus and such. And those all go in the Windows logs. There's 3 main logs: application, system, and security. Application is whatever an app developer chose to put in there. It's usually not very interesting, like an application update or something. The system log is non-security system events, like a service load, things like that. And security is security significant events, like login and log off, changes in policy, and so on. Those are the 3 basic logs that have been around forever, all the way back to Windows NT, I think. I certainly used them on Windows XP anyway, and Windows 2000 too. So the log locations are specified here, and here's where they are typically in WinEvent Logs, Application, System, and Security, and they are a database in a Microsoft format, EVTX. And for Vista and later, they are XML files because Microsoft stopped making proprietary binary formats for everything and switched to text-based XML to be much easier to parse, much more compatible, and so on in the future. Around the same time, they switched it for Microsoft Office files, which are also now XML files. And so there's another thing called the Application and Services logs, which will have things like Task Scheduler and Windows Firewall and other things. Now, when you have a log, it's going to have a source, which is the program that created the log, and then an event ID number, which is the thing. Now, there used to be this great website called eventid.net, but it seems to be gone, which is a real shame, because the Microsoft source to tell you what these event ID numbers mean is almost useless. They will give you a really generic description and no help. And there used to be like a forum where real administrators would record their experience of what this event dogs do. You can still Google them and find some stuff, but there isn't one central location anymore like there used to be, because that was the most useful stuff. People would say, here's what causes this event, here's how you fix it. You really need that kind of help, because these things are really hard to understand, and the Microsoft documentation is not much use at all. But anyway, some of them are pretty easy to understand, like logon events, 540. It tells you there was a logon process logged in with NTLM, and it came from this IP address and a workstation name, so you get a lot of information. And here's from the Event Viewer. It'll show you the security identifier. The logon type is 5. We're about to talk about them. A new login and detailed authentication information, the login process, and so on. Timestamp. It does give you a lot of information about each login. And so the login ID is a session identifier, and login type tells you what's going on here. This is an unlock. This is a remote interactive, somebody connecting with like RDP remotely. And I'm not quite sure what these other ones are. Interactive batch. Anyway, gives you a clue where they came from. And so login process tells you what process initiated it, like Kerberos, means they're logging in with into a Windows domain. And the authentication package used, the name of the source system, and the source network address. So that's real important, because attackers will get malware on one system and they will take control, and then they will hop to another and steal credentials, and you will find a trail of login information going through the network. As they do this, it's often useful to track lateral movement. So here's an example. Your attacker gets interactive access to a Windows 7 by getting someone to install malware on it, so they have a backdoor. That's in a corporate domain, so the backdoor runs under the domain user who owns that workstation. So that's Acme Eve. They steal passwords, hashes or something, and then they move across. Now they have a local and a domain administrator account. Then they move across. So you mount the $C share for workstation from there. Do net use, you connect to the $C share, which will give you access to it. on another workstation, beta from alpha, using a local administrator term. Then you use psexec to execute a command on that and execute some malware. Now you have a remote desktop connection to another one. You connect in with RDP. You browse to an IIS server that requires authentication, and you use some stolen credentials. So you see you're creating a lot of login events as you hack through the system here. So the first one's going to give you a type 3 login because he came in for the first machine. Then he's going to have a type 3 again because he went through a domain account onto a share, and you'll see events for that. You'll get a remote interactive here. This is, I think, the use of the thing that launches remote process, psexec. This is IIS authenticating. We'll give you another login type 3. And you'll have extensive records of each of these things happening you can use to track it down. So if you create a user account or delete one or disable one, it will record that as well. Policy changes will tell you things. If you change the policies that record what is logged, which is something an attacker might do to try to stop logs, like clearing the logs, there'll also be an event recording that. And that's a common thing that hackers do, of course. So process auditing is unfortunately not on by default. You can log every process. This is one of the many cool things you can get by putting sysmon on your machine. You can turn it on in group policy, but the Microsoft default system will create a lot of log events every time you launch a process. What's a lot more fun is to use sysmon, which makes really handy logs. So by the way, it does record by default when services start and stop. So if you make your malware into a service, which is common, it'll be recorded. And so here's psexec. The psexec service was entered the running state, was stopped, and so on. So if somebody is using the Microsoft tool psexec, which attackers commonly do, you will have records of when that was used. So suspicious things. People using psexec that shouldn't be. Bad service names. Notice errors from binaries that are deleted but still referenced by a service. That's the sort of thing. So the service tries to start, but the executable is gone. So that will create an error. So you check for your antivirus. This is, of course, obviously very handy. If your antivirus picked up something, then you'll have a really good clue what's going on and what time to look at. The default logs are not very big. They will overwrite themselves, so it's very common to increase their size. Although much, much better, of course, is to forward them to a central log analysis server like Splunk, not even store them locally. And that also means the bad guy cannot easily erase them. Even if they erase the local log, it's too late because they've already been forwarded to the central log server. By the way, these EVT files, like Microsoft database files, they tend to get corrupt a lot, and so there are tools to fix a corrupt EVT file. So here's a few of them. The event viewer is the built-in Microsoft tool to let you look at the event files. And there are other ones like log parser that lets you use SQL queries and other ones. But for us, of course, we're just going to use Velociraptor. All of it is in Velociraptor. It's easy to use, so much nicer than all those other tools you used to use. So the first thing you do is you install sysmon. Sysmon is another Microsoft sysinternals tool. It is fantastic. Sysmon gives you nice, easy to understand log entries, which we saw in built-in Splunk. Just one for launching a file, one for launching a process, one for creating a file. A nice, clean event, including things like MD5 hashes and all sorts of useful information, and not wasting your time with hundreds of irritating events that don't tell you anything useful. So sysmon is the champ. You can just install it remotely with Velociraptor, and then you can harvest the logs. With Windows Event Logs, you can harvest any logs you want. You can also just tell it to harvest just the sysmon logs, which is something we'll do in the projects. And it's very handy. All right. Then there's scheduled tasks. This is the equivalent of Microsoft's or Linux's cron jobs. You can do it in the command line with the @ command. At this time, execute that program. Then you can tell it to do it every Monday, Tuesday, and Wednesday, and so on. You know, you can run these programs at certain times. With the @ time, there's also a GUI called Task Scheduler where you can make these things. The SCH task commands is another way to do it from the command line. And when you do them, there will be job files, which persist until shutdown and reboot of system. They're recreated when you reboot. It creates the necessary job files, and they find them in system root tasks. And so you have task scheduler logs available in a text file that records the start time and completion of tasks, and it'll also make event logs in the security log. when scheduled tasks happen. So the job file itself is a binary file, but if you just look at the strings, you'll see the user information in the file path. There's also a Python job file parser, if you want it, that will give you all the information in there. Don't start if on batteries and things like that. So here's the log showing you the service started. This job was created, a.bat, at 2.job finished, and so on. It just tells you which scheduled task that took place. And you'll find an event viewer, the same thing. So this user registered task scheduler task at 1, updated it, launched something, and so on. Just everything you do is recorded in this log as well. And we've seen some of this before when using, say, auto runs. We'll pick these up. And you can harvest them, of course, with Velociraptor. So this will give you all the task jobs, which are XML files. It will upload them, analyze them, and give you an overview of the commands executed and the user who ran them. So, like almost every forensic artifact, Velociraptor is there to make it easy for us. All right, let's do another Kahoot. This course used to be much harder. We used to do all this junk with Microsoft tools, which is really annoying. Velociraptor makes it much easier. Trying to get a better signal? Yeah. Yeah, it can. I've done that. Sometimes opening the window helps too. You don't like the Wi-Fi, eh?
No.
That's fine. Oh yeah. It's a good security policy not to use public Wi-Fi. Some of us are slobs and we don't care, but you're right. It's safer to avoid it. The 5G or 4G is much safer because it's not shared. Well, mine certainly is, but especially now that I know if I do get malware, they can just steal everything out of my LastPass vault. That's a little annoying. I didn't know that until last week. So now I'll probably get a little more paranoid. I don't know. We'll see. Anyway. All right, I see Velociraptor got in. Looks like we got all 6. I'll just wait for the music to go around again. Yeah, people said that. Yeah, good. Oh, okay. Good. All right. So a complete copy of a whole volume. Where are you going to find that? All right, that's the shadow copy. All right. All right, so what item prevents your 32-bit apps from messing up your 64-bit system? Yep, that's the redirector. Good. All right, so where are login attempts recorded? Yeah, they're in security. That's a security event. They're stored in security logs. All right. And where do you have one instance per task? Job files, the equivalent of cron jobs on Linux. Those are the files that launch scheduled tasks. And which item persists until reboot? That's the job file. You know, scheduled tasks are amazingly useful. There's a time like 10 years ago when I taught the CISSP and we had an expensive practice test and I wanted to share it with the class, so I put it on a server and I tried to find some way to share it, and I made scheduled tasks to run every hour of every day for the whole month. So there was 24 times 30 of them, and you could change the password on the one account by reserving something. I wrote an ASP script that did that, and it worked just fine. I thought that was insane, but just having a scheduled task for every hour turned out to be enough so we could share that thing. Anyway, so, all right, I know who that is. It may be only one Dave. My grader will attempt to figure it out. All right, and I don't need to figure out. All right, so I'm going to stop the recording and